Okay, so I believe we previously we have discussed how to choose the fibers, what are the criteria and things like that. So let's talk about the types of fibers and its properties, and it will be a list of it will be linked to the fibers also. So this thing over here should be also with this. Alright, but I'll just put it over here because yeah. Anyway, so let's just the purpose of this video is to introduce the types of fiber, alright, briefly. And then later on in the subsequent videos, we'll talk about the fiber in a more detailed way. So there is actually three types of fiber: the glass, Kevlar, and carbon. Alright. So its properties will be also briefly discussed over here, or later on we'll also be discussing it in more detailed ways later on in subsequent videos. So in this video is somewhat the summary of what we're gonna say later on, and then after that later on in the videos we'll discuss each of them individually. Alright, so in order to start, let's carry on with this page 66 of your thing. Alright, so this graph over here tells you that there is a stress strain system. Alright, and why is it linear is if you still remember, for normal metal material, alright, you have an elastic over here. After this U point, you'll start to deform and eventually break. For composite, alright, it is linear, and up to the U point, it breaks. That's all. It has no deformations. It breaks means break. Why? This is because it is a very stiff material. So that's why it doesn't actually have any form of ductility or any form of deformations. So it straight away break, and that's it. Alright. So with this understanding, let's talk about why, and therefore you will know that this is no U point and a very low strain to failure. Alright, so a high strain to failure means that it can tahan a lot of strain before it fails. Very low strain to failure means that just a little bit strain, it breaks already. Alright, that's it. So we have three types. Alright, the first is the carbon. There is another carbon over here, and there is another glass type, so I use a different color. While the Kevlar, alright, is just by itself. Kevlar, in other words, is called the aramid. Alright. So the purpose of this graph is to illustrate to you the compressive strain versus the compressive stress, while tensile strain versus tensile stress. Alright. Over here, sorry, if you want to choose a good similar compressive and tensile attributes, alright, meaning in good compressive good compressive stress and good tensile stress. Alright, so if you want good compressive stress and good tensile stress, choose IM carbon. Alright, IM carbon is called the intermediate modulus carbon. Later on in the subsequent videos we'll talk about it. Alright, and the form of this name is based on the temperature of how it's being made. Alright, just a side note only. Alright, so if you want a good compressive and a tensile stress, alright, you can, if you want to tahan high stress, use IM carbon. Alright, if you want to tahan high strain, alright, then you can use the S glass. Alright, so you can tahan more strain if you think about it. Alright, as for the E glass, which is the electrical properties for the glass fiber, alright, it is somewhat different, somewhat the same but a little bit different. The strain is over here. The length is, as you can see, the actually about the same anyway. But as you can see, aramid itself is quite big difference already. Alright, it has very low compressive abilities. Alright, yes, low compressive strain and low compressive stress. Alright, but it have very high you have a very high tensile strain and a tensile stress. Alright, so it's somewhere in between the carbon and the S glass if you think about it. Alright, and comparatively I think S glass is still better than aramid lah. Alright, but if you were to mix some things, aramid is actually quite strong also. Alright, things like that. And fiber is a material that mix silica with other materials, alright, in order to create certain properties. And just a side note is that silica is formed by silicon. silicon doesn't come naturally. Alright, it has to mix with oxygen in order to become silica, which is your sand, your dust, whatever. It comes naturally, like in the sense that it is formed through chemical reactions with oxygen. So naturally silicon is hard to get. You have to break down silica or from its oxygen. You have to remove the oxygen element in order to get silicon back. Alright, so normally when we get silica, which is just a sand-like looking stuff, alright, yeah lor. So silicon, you get silica mixed with other materials, you'll get other stuff. Alright, so in other words, when the material comes in, it already comes in silica form, so straight away you mix with other materials. Unless you want to make silicon, then you reverse the process. Alright, so glass fiber is this form lah. So glass fiber is very related to silica if you want to talk about it. Alright, later on in the subsequent videos, my explanation on silica sucks, but at least finally you still can get the answers from there. Next is carbon fiber, alright, where it's a controlled pyrolysis. Alright, given that the meaning of pyrolysis, alright, is to decompose your material, alright, using high temperatures. Alright, so this is why I say just now that iron carbon, alright, the intermediate modulus or high strength carbon, alright, is mainly on the temperatures, how you break down it. Alright, so the range of carbon fibers depends on the different temperatures, elevated temperatures. So oxidation has its own temperature, about 200 degrees, carbonization about 500 plus, graphitization about 1000, things like that. So different temperatures will give you different mechanical properties, alright, strength and stiffness. Okay, knowing a bit about the fibers, let's talk about the structure of fibers. Alright, where just to take note that the max tenacity is the ability of the maximum break strength, or the maximum strength that you want. Alright, and in order to have this high strength, alright, and initial modulus, alright, one way is to have extended chain configurations. Alright, so extended chain configurations, I would believe, is this one, fully extended chains. Alright, so I think this is stronger, I guess, or perhaps this partially extended chains. Let me think about it, because he say in the future he will discuss this again. Alright, but nonetheless, almost perfect crystalline, alright, is if you were to have this form, they are all arranged very perfectly, very neatly. For a half aligned crystalline, they are a bit sengek. Alright, they are a bit sengek. For a totally random crystalline, they are all random. Alright, as you can see, they're all random. This one is neatly arranged. This one is half neatly arranged, half not neatly arranged, if you remember. Alright, but anyway, so if you want a good strength, you want to be as close to this, and a good extended chain configuration. I don't know what type of chain. Alright, and flexible. So the structure of the fibers where you lay them, if it's flexible, is like that. If it's a spin drawn, meaning you spin all of them together like that, alright, like you mix them all together, you have this thing like a ball. Or nonetheless, you can also have a partially extended chain. So it all comes in a different way. Alright, what it means that dilute solution means that you put a little bit of the fibers, you have this thing. Alright, if you put a little bit of the fibers in this way, rod light. Flexible is you can like for the rod light is very stiff. Alright, so if you have a flexible one, you put in more, you'll become like that. If you put in more, you'll become spin drawn. Or if you spin drawn it, I don't know. But anyway, if you put more rod light, it'll become this form, spin orient, or I don't know whatever. But anyway, yeah. Polyester and glass, they have flexible chain, which is this one. Alright, their properties is very flexible. Alright, as for Kevlar, alright, it is very rigid, which is just one line like that. Okay, so this is just the meaning of that. In the future, he will discuss again. Okay, so which is that the drawn directions. Alright, So I will believe the drawn directions means that you have a matrix over here. Alright, the drawn directions means that you draw it in this way or you draw it in this way. These are all the way you arrange. So instead of saying it's a arrangement of the fibers, you say it's being drawn. Alright, I think I may be wrong. There will be a deeper meaning in that. Alright, so if you were to draw glass, ceramic and carbon fibers, it will lead to different structures. Why? Because look at how they are being arranged. For the glass fibers, they are very flexible, as you can see. So if you put more of it, alright, it will become a ball-like. For Kevlar, they are all rod-like. So if you were to put more, it will become like this. A lot of rods, like mix here and there. Alright. So this is why the method of arranging the glass, ceramic and carbon fibers give you different structures also. So this is just the meaning of that. Alright. So for glass fibers, alright, it is formed by melt drawing. Alright, melt drawing means that you kind of have this furnace over here, alright, and you pour materials inside, and it slowly melted. Alright, melt it, and then you have this very small thin diameter where you feed out the fibers. So the fibers, if you were to zoom into the fibers, alright, you kind of see that there is also a arrangement that is aligned, I think. So I think this is a way to also have the drawn directions. Drawn directions, I believe, is how you draw it out. Alright, so you put the material in, how you pull it out, how you pull the material out. So if you pull this material out, then this material is its strength is in this direction already. So you have to know what direction is it drawing and things like that. And this way, the glass is actually an isotropic material, alright, where it is same strength in all directions. Okay, so I will believe the drawn direction, alright, is not this thing already. Alright, if you come to think about it, is how you extract the material. Alright, so if you extract the material like that, then this is the direction that you're talking about. If you extract in this direction, then this is the direction that you're talking about. So it depends on how you extract the material out from the machine, I think. Alright, maybe wrong. And then ceramic is formed by wet spinning and drawing. So wet spinning is that you have to dissolve the polymer inside a solvent. So you have to wet it first. So after you wet your material, alright, which is inside this why is my thing like that? You give me a while. So over here is where you feed your material in. Okay, so once you feed it inside already, you wet it first. So this is the wetting area, I think. So it's like a bath. So you wet whatever thing that you want. There's a mixture in it. Then once you wet already, you pull it out and you create a strain of it. Alright, and then you kind of wrap it out all together into a roll of material. So after that you can sell it or whatever. So this is like a wet spinning process. Alright, and for ceramic it is formed by this process. Alright, and as for carbon fiber, it can be also with this process, but also in terms of oxidation and carbonization, where is a temperature process. Alright, where you have to elevate the carbon fiber to a certain temperature, alright, using either of this method. Alright, so ceramic is this one. Be careful when you read it. For ceramic is this one, for carbon fiber is this one. They should highlight this, but I think they forgot. So for ceramic and carbon fiber, they are anisotropy, meaning they have certain strength in one direction. So different properties in different directions. That's all it is. Okay, and I think this is all it is. So the key takeaway from this video is most of it is this graph over here. You have to know what type of material, compressive or tensile. So if you want a good stress, either compressive or tensile, you can choose the IM carbon. If you want good strain, then you can choose the S glass. If you want something in between, I would suggest you can choose this one, the high strength carbon. Alright, and if you are talking about applications not very stiff or barely good strain or whatever, you can use Aramaic, I don't know. So these are things that you need to articulate. Alright, and the next thing over here is the way it's being drawn. Alright, and isotropic and anisotropes. And yeah lor. So another thing is that you have to remember, all in all we are talking about glass fiber, Kevlar fiber, or carbon fiber, 3 types. So this is just a brief summary of all of them. So later on in the subsequent ones, we'll actually go into more details, which is all this. Alright, glass, Kevlar, and carbon fibers. Alright, so I shall see you in this series of stuff.